one more time that we are about to begin our event today. So I would like to remind all of the participants that still outside of this room to come to this room, and we are going to start this event. Thank you.
Dua, tiga.
Good morning, ladies and gentlemen.
The Honorable Director, sorry, the Honorable Directorate General of Housing, Ministry of Public Works and Housing, Mr. Iwan Suprianto, STMT,
Vice Rector for Academic, Mr. Agustin SAMBADBA,
Vice Rector for Planning, Collaboration and Information System, Mr. Yusran Saadi, PhD,
Head of Research and Community Service, Mr. Muhammad Ali, PhD,
the Deans of University of Mataram,
the Chairman and all committees of today's conference,
and a very warm welcome to all keynote speakers, invited speakers, and all speakers of today's conference.
and all distinguished ladies and gentlemen.
I am Almer,
And I'm Laili.
the MC for today's event, and it is such a huge honor for us to be with you on this lovely Monday, November 14, 2022, in our event, the 7th International Conference on Science and Technology 2022. With the theme Smart Innovation, Research on Science and Technology for a Better Life. The 7th International Conference on Science and Technology 2022, or ICST, is organized by Institute for Research and Community Service, or LPPM, University of Mataram. The conference is continuation of conference series on science and technology, of which the previous was held in 2016 until 2022. ICST 2022 aims to provide an environment for researchers to discuss the current state of the science and technology in industries, universities, and companies.
This conference is hosted by University of Mataram, co-hosted by University of Andalas, Indonesia, and Binus University, Indonesia. And also we would like to thank you to the partners and sponsors. Those are Bakri University, University Technology Mara Malaysia, University Sumatera Utara, University of Liverpool, Norwegian University of Science and Technology, PT Sagita Buser, CV Total Karya Bersama, Nindya Sakna KSO, Modern HK Inovasi untuk Solusi. And I would like to welcome everyone here to the island of Thousand Mosque, Lombok, where you can find beautiful destinations not only to study but also to enjoy your holiday. We really appreciate your presence, and we hope the program that we have lined up for you to be fruitful and
Ladies and gentlemen, let us deliver the agenda for today's. The first one is singing the national anthem. The second one is chairman report. The third one is welcoming remark. Fourth is opening remarks. 5 praying. 6 dance performance. 7 keynote speech and parallel session. And the last one is closing speech. To begin our agenda, let us sing the national anthem of Indonesia that will be led by Laili. Ladies and gentlemen, please kindly stand up. Thank you, ladies and gentlemen. Please kindly be seated. Moving on to the next agenda, that is the report from the chairman of this event. Ladies and gentlemen, please join me in welcoming Professor Buan Ansari, PhD, with a round of applause.
Bismillahirrahmanirrahim. Your Excellencies, Rector of Mataram University, Rector of Andalas University, Rector of Bina Nusantara University, Vice Rector for Planning, Collaboration and Information System Affairs, Mataram University, all deans of 9 faculties and Director of Postgraduate Program, Head of LPPM, Head of LPMP, distinguished keynote speaker and invited speakers, distinguished participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning. First of all, let us thank to Allah Subhanahu wa Ta'ala and all praises to Him who has given us the mercies and blessing that we can attend this meeting on site in this venue, Lombok Raya Hotel, and join virtually from around the world and all parts of Indonesia. Secondly, do not forget salawat and greeting always pour out for our Prophet Muhammad sallallahu alaihi wasallam, who taught their people in goodness. A warm welcome both to everyone who are joining this conference, and it's a delight to have you all with us today. Alhamdulillah, this morning we are able to meet in Lombok Raya Hotel and join virtually by using Zoom meeting platform. On behalf of organizing committee, it gives me a great pleasure and honor to welcome you to the 7th International Conference on Science and Technology hosted by University of Mataram and University of Andalas and Bina Nusantara University as co-host. Greatest news for all participants that in the 7th ICST 2022, all accepted articles will be published by AAP conference proceeding, which indexed by Scopus and Web of Science. For your information, in this 7th ICST 2022, there are 14 keynotes and invited speakers, 108 presenters, which consists of 23 participants come on site to present paper, and 85 participants would present papers visually. It's mean double in terms of the number of participants compared with the previous ICST in 2021. Ladies and gentlemen, I would express my deep gratitude to all keynote speakers, invited speakers, and the presenters who submitted their papers to this conference. The presenters who joined this conference come from United Kingdom, Norway, Australia, Japan, Malaysia, Taiwan, Uni Emirat Arab, Brunei, and Indonesia. Several excellent and invited speakers will present his work funding in this conference. Consists of Professor Mikrazuddin Abdullah from ITB, Professor Wahyu Jatmiko from Universitas Indonesia, Professor Ahmed El Sheikh, PhD from University of Liverpool, Professor Carl S. Ryder from University of Leicester, UK, Professor Stergios Kontinuus from Norwegian University of Science and Technology, Norway, and another incredible invited speaker, Professor Muhammad Lutfi Idris from University of Bengkulu, Professor Dr. Wen Sao Chang, the University of Sheffield, UK, Dr. Hiroyuki Miura from Hiroshima University, Associate Professor Dr. Rohana Hassan from University Teknologi Mara, Shah Alam, Malaysia, International University, Malaysia, Eka Sunarwidi Prasidya, PhD from Mataram University, Professor Diding Suhandi from Lampung University, and Professor Muhammad Ilhamdi Rusdi from University of Andalas, Padang. Hopefully, the conference would provide international forum for sharing knowledge, research expertise, forming a network, prospection, collaboration, and working on various fields of science and technology. Ladies and gentlemen, I would express my deep gratitude to university partners such as Bakri University, UITM Mara, Malaysia, Hiroshima University, USUS, and with Liverpool University, and the sponsors are PT Hutama Karya, PT Nindya Sakna, PT Modern Surya Jaya, PT Sagita Buser, and CV Total Karya Utama for their generous support in this event. I would like to express sincere thanks to Directorate General of Housing, Ministry of Civil Work for very kindly delivering welcome remark in this conference. I would also like to express interest for the tremendous teamwork in making this event in reality.
Mataram, distinguished speaker, guests, and participant, chairman, vice chairman, and steering committee of the 7th International Conference on Science and Technology 2022, ladies and gentlemen. A very good morning to all of you. A very warmly and respectful welcome to the 7th ICST 2022. It's indeed privilege and an honor for me to deliver a welcoming remark this morning. Also, I would like to apologize in advance that I am unable to attend this conference in person. Distinguished guests, ladies and gentlemen, in the last 1 year, we all go through very dynamic occurrence in terms of social and economic situation, which strengthen our awareness about interconnection among region and sector. It shows us there is no solely event actually. In single event, certain region will affect other people who live in another part of the world, either direct, indirect ways. The most obvious example is the COVID-19. Here we see clearly how the issue in health sector interrupt every aspect in our normal life to the level we have never experienced previously. Furthermore, based on the scope of my responsibility as Director General of Housing, the spike of fuel price that affect the cost of housing production and the increasing of interest rate to compensate global economic turbulence led to weaken the household affordability to buy their first house due to the higher housing price and housing mortgage. The condition, as I described above, is a challenge for us to innovate and find practical solutions to improve our life quality. To all you, the outstanding scientists, the biggest challenge is ensuring the research finding be more practical, applicable, and be a part of policy solution so that provide widely benefit to the community. The topic, Smart Innovation Research for Better Life, I hope will encourage us to utilize the 7 ICST forum that widely recognized as place for the outstanding scientists to present the latest research finding and innovation to produce smart and applicable solutions to enhance our living quality. Before we get started, I would like to extend a special welcome to all the incredible speakers in this event today. Professor Dr. Mikrajudin Abdullah, Professor Dr. Wisnu Jatmiko, Professor Ahmed Elsik, Professor Carl Ryder, Professor Stregios Gautianos, Associate Professor Dr. Tukvo, and to all brilliant invited speakers that I cannot mention one by one. Ladies and gentlemen, at last, let me take this opportunity to express my gratitude to all of you for participating in the 7th International Conference on Science and Technology. May you enjoy this discussion and may wishes for a pleasant stay in Mataram for you who attend this conference offline. Thank you. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you. Distinguished ladies and gentlemen, we humbly present Vice Rector for Planning, Collaboration and Information System, Mr. Yusron Saadi, PhD, to deliver a welcoming speech as well as to open this event officially. Ladies and gentlemen, please welcome him with a round of applause.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Distinguished guests, rectors of university partners, keynote speakers and invited speakers, my colleagues from University of Mataram, here many deans, and also the head of research office also attending here this morning. University partners, again, I am very happy that we can join together in this conference. Participants, ladies and gentlemen, I would like to express my welcome to the 7th International Conference on Science and Technology. I remember I was in the same conference 2 years ago. I was representing Pak Rektor to give opening remarks. So I'm happy that this conference, like Pak Chairman said, is a continuation of the 6th previous conference. I'm very proud to be here with expert researchers and academia from many countries Particularly today, we have Professor Sergius from Norway, Professor Wisnu from Universitas Indonesia, and also professors and experts who cannot join with us today but unable to attend online. This conference will surely provide an excellent opportunity for sharing knowledge in the field of smart innovation research on science and technology for a better life. 2 years ago, I remember the theme is Science and Smart Innovation Technology for New Normal Condition in Industrial Era 4.0. I noticed, as the chairman said in his speech, the aim of the conference is to provide an environment for researchers to discuss the current state of science and technology in industry, university, and companies. The presence of keynote speakers and invited speakers from various countries really enrich this scientific meeting. It can be expected that there will be an interesting exchange of information, especially in terms of scientific development and other technological innovation. Distinguished guests, rectors of partner universities, keynote speakers, invited speakers, ladies and gentlemen, despite smart innovation research is often discussed everywhere, its implementation has not reached the expected level. The disparity between developed and developing countries mean there are also considerable gaps to be filled in. Therefore, intense interest from participants who will be presenting more than 100 papers on science development and research finding on smart innovation and technology are clear signal that there will be a positive impact from this conference. It is also expected that the conference will create partnership and alliances between universities, industries, and other organizations, which allow co-sharing information and research and development sources, and also to gather the potential of existing knowledge to finally configure the smart innovation research at a larger scale. Distinguished guests, rectors of university partners, keynote speakers, invited speakers, participants, ladies and gentlemen, we have to take this exciting conference forward to make it beneficial in the development of our society. I do believe this event will generate discussion which can be transferred into real works, as in this modern era, there is a strong emphasis on putting theory into practice. Again, I would like to express my sincere thanks and appreciation to the organizers of the conference, university partners, keynote speakers, invited speakers, and also to the sponsors who contribute to this event. To all participants who have joined the conference from different countries, I would like to extend my very warm welcome to this conference. I wish you all have a productive and fruitful conference. Finally, before I declare this conference formally open, I would like to take this opportunity for the participant not only to enjoy this conference, but also to spare your time to explore, to enjoy our beautiful Lombok Island. Please do not concentrate on academic matter only, but refresh your mind to enjoy Professor Sergios, Professor Wisnu. I believe the organizers will be very happy to accompany you to your selected destination. This small island is offer many places to go, and within very short distance, you can spend a day to explore many part of these places, this island. And I believe we will be very happy. The Lombok people will welcome you to enjoy, to experience the scenery. Finally, ladies and gentlemen, in the name of Allah, the most gracious and the most merciful, I declare that the 7th International Conference on Science and Technology, ICST 2022, is formally open. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Thank you, Mr. Yusron Saadi, for the welcoming speech. Let us move on to the next agenda, that is praying, that will be led by Mr. Umam. So, Mr. Umam, please take your position.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Let us bow our head for a moment, pray to God Allah subhanahu wa ta'ala, so that our international conference can be precious to all of us. I will lead this prayer based on the teaching of Islam, and those who are not Muslim, you are pleased to pray according to each of your beliefs. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين اللهم اجعل جمعنا هذا جمعا مرحوما وتفرقنا من بعده تفرقا معصوما لا إله إلا أنت غني ونحن الفقراء اللهم ارزقنا علما نافعا ورزقا طيبا وعملا متقبلا اللهم ارزقنا فهم النبيين وحفظ المرسلين وإلحام الملائكة المقربين برحمتك يا أرحم الراحمين. Oh Allah, today we gather here to bring about an international conference on science and technology. Make this international conference as a useful science assembly, as a medium of sharing useful ideas, knowledge, and experience of scholars, researchers, and students of various disciplines. May the conference we organize today benefit to our lives, broaden our knowledge, shine our ideas, and lead us to be successful, productive person, which in turn will boast dignity of our nation. Oh Allah, guide and bless our heart and our minds with the like of your guidance. Impart your supreme wisdom upon our activities. Help us to speak our minds clearly. Help us to listen to each other, respect each other, love each other, so that we are included to be blessed person. Oh Allah, protect us from unintended temptation, show us the right path and give us knowledge and strength to perform good things. Show us and make it clear the bad things and give us knowledge and strength to avoid them. Oh Allah, you are the one who can fulfill our dua. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا آتنا من لدنك رحمة وهيئ لنا من أمرنا رشدا. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. السلام عليكم ورحمة الله وبركاته.
Thank you, Mr. Umam. Distinguished ladies and gentlemen, here I think is the most awaited agenda. That is one of Lombok's traditional dance performance, namely Gandrung, that will be presented by Santras. So here, ladies and gentlemen, let's welcome Santras with a round of applause. you go. That is very beautiful performance from Santras. Thank you. Well, ladies and gentlemen, before having the break, I would like to invite all of you to come forward here for the photo sessions. So yeah, I would like to invite all of you. Please come forward for the photo session. Please stand up and come forward. I think I would like to invite all of the participants in this building to join us for the photo session. Okay, so maybe we'll ask the gentleman to be on the stage, or maybe the ladies. Okay, it's fine. Ladies and gentlemen, let me lead this photo session. So, which camera do we use? Kamera yang mana kita pakai? So, please look at this camera, and I will do a countdown from 3 to 1. Okay, let me lead the photo session. I will do a countdown from ready? 3, 2, 1, cheese. Okay. One more time. 3, 2, 1. Okay. Can you please also follow this position, yeah? So when I say Unram, you will say Jaya, okay? Like this. So when I say Unram, please say Jaya, okay? Ready? 1, 2, 3. Unram. Jaya. Unram. Jaya. Thank you. Thank you so much. Please have a seat.
Ladies and gentlemen, before we continue to the main session, we will have a break for 30 minutes. We have already provided you with some coffee and snack outside of this room. So please kindly take as much as you please, and we will see you again at 10:15 a.m. Thank you, and please enjoy your meal.
Yes, so we already provide you with some snacks outside of this room. So for those who want to have some snacks or maybe coffee, you can please enjoy your meal. Thank you. We will see you again at 10:15 a.m. Lombok's time.
University of Mataram was established on October 2nd, 1962. Located at the heart of idyllic island of Lombok, which renowned for its beauty, natural and cultural diversity, make Mataram University poses a great opportunity to explore knowledge. Becoming internationally competitive research-based university, ignite the passion for Mataram University to continue pioneering intellectuals by creatively applying their knowledge in research and discovery. Nurturing talented youth to become future leaders who eager to pursue the truth based on faith and piety, give Mataram University a firm ground to contribute at its best to the society. In 2018, Mataram University is ready to answer the call with 9 faculties, 58 departments, study programs, postgraduate programs, vocational programs, diploma. Faculty of Economics, Faculty of Animal Husbandry, Faculty of Agriculture, Faculty of Law, Faculty of Teacher Training and Education, Faculty of Engineering, Faculty of Mathematics and Natural Science, Faculty of Medicine, Faculty of Food Technology and Agro-Industry, Study Programs, Communication Studies, International Relations, Sociology. Mataram University mission in optimizing research and discovery, enhanced with facilities and accessibility for the students and researchers, as well as stakeholders with same common goals in supporting education to solve humanity problems, to fulfill our social responsibility. Hand in hand with the society, Mataram University never to choose run alone. We prefer to walk together through collaboration and joint cooperation with partners from every corner of the world in exploring knowledge, science, and technology. Mataram University commit to find the best way in increasing society's quality of life. We have tasted the same hard times. We have swallowed the same sour times. We have passed the storm of challenge and stay strong.
Sebagai Sekda Provinsi Nusa Tenggara Barat,
Ketua DPRD Provinsi Nusa Tenggara Barat,
Direktur Jenderal Prasarana dan Sarana Pertanian, Kementerian Pertanian Republik Indonesia.
Saya sangat bangga melihat perkembangan Universitas Mataram yang begitu maju.
Saya merasa bangga menjadi bagian dari Universitas Mataram.
Dan kami sebagai Ketua DPRD mendorong agar Universitas Mataram sebagai sebuah universitas berbasis riset sesuai dengan visi misinya pada tahun 2025.
Saya yakin Universitas Mataram akan mampu meraih visi dan misinya.
Universitas Mataram sebagai salah satu perguruan tinggi yang mumpuni untuk mempersiapkan kader-kader penerus.
Assalamualaikum warahmatullahi wabarakatuh.
Selamat datang di Universitas Bakri. Universitas yang memiliki visi, a globally recognized university through engagement with industries and experiential learning methods. Berawal dari Bakri School of Management yang didirikan pada tahun 2006, Universitas Bakri resmi bertransformasi menjadi salah satu universitas di Indonesia di tahun 2010 dengan 10 program studi. Saat ini, Universitas Bakri telah memiliki Magister Manajemen Program, Double Degree Program MBA, dan Dual Degree Program of Bachelor. Kerjasama internasional yang mapan juga terjalin dengan puluhan institusi luar negeri, telah dituangkan melalui Double Degree Program, Student Exchange, dan juga Collaboration Research. Transformasi besar satu dekade yang telah berhasil membawa Universitas Bakri di tahun 2021 sebagai perguruan tinggi swasta kedua terbaik se-Indonesia. Universitas Bakri berhasil meraih peringkat ke-138 dari 5.116 affiliation yang tercatat dalam database Scientific and Technology Index. Ditandai oleh keberhasilan para dosen dalam meraih pendanaan penelitian nasional dan World Research Grant dari pemerintah Indonesia.
Untuk meningkatkan daya saing bangsa, kelompok usaha Bakri mendukung penuh Universitas Bakri di dalam proses perkuliahan, penelitian, dan inovasi. Melalui kolaborasi yang erat, bersama-sama kami siap menghasilkan sumber daya manusia yang unggul.
Sebagai industrial university yang menerapkan metode experiential learning, Universitas Bakri memiliki jaringan kerjasama dengan berbagai instansi, universitas, dan berbagai sektor industri dan luar negeri. Mahasiswa tidak hanya akan berinteraksi dengan para pengajar, tetapi juga dengan para tokoh nasional dan internasional, praktisi, serta para CEO dan jajaran direksi di dalam kelompok usaha Bakri.
Saya memilih Universitas Bakri karena dihadapkan dengan dua pilihan, apakah mau menjadi seorang followers atau menjadi seorang leader. Dan saya memilih untuk menjadi seorang leader. Universitas Bakri membekali saya kualitas pendidikan yang luar biasa dari para dosen. Dan ini yang menjadikan saya seorang entrepreneur sejati.
Berlokasi di lingkungan yang sangat strategis, terletak di epicentrum kota Jakarta, semakin meningkatkan mobilitas dan kesempatan para mahasiswa untuk merasakan pengalaman langsung berinteraksi dengan beragam stakeholder. Universitas Bakri juga menunjang pembentukan karakter dengan nilai profesional, caring, dan inovatif. Dengan unit kegiatan mahasiswa yang mengasah keterampilan mahasiswa untuk mengikuti kompetisi pada tingkat lokal, nasional, maupun internasional.
Pendidikan yang berkualitas dan menghasilkan para lulusan yang memiliki jiwa kewirausahaan dan inovator yang kreatif tanpa batasan bisa memimpin lapangan pekerjaan di dalam negeri maupun di luar negeri hanya bisa didapatkan di Universitas Bakri.
Didasari cita-cita membentuk SDM yang unggul, Universitas Bakri merupakan ekosistem akademik yang mendukung setiap mahasiswanya untuk terus meraih berbagai prestasi dan siap mengantarkan untuk menciptakan inovasi serta solusi bagi Indonesia dan dunia. Universitas Bakri, experience the real things.
Unram University is located in Padang City, which is the capital city of West Sumatra, endowed with a beautiful geographical area and religious community. students are involved in character building, reflected in a variety of relevant activities, engaging faculty members and communities. The university's unique academic structure also promotes interdisciplinary collaboration and allows the faculties to teach across related disciplines. To support equal access to higher education, Andalas University provides various scholarship schemes. During their studies, students are involved in character building, reflected in a variety of relevant activities, engaging faculty members and communities. Summed up in the acronym SEJATI, which means patient, empathetic, honest, fair, responsible, and sincere. Interdisciplinary knowledge, in consultation with key industry experts, enables the faculties to develop programs that will better prepare students for working in industry. It has resulted in close industry links being built through strategic alliances with trade associations and key industry partners. Here the student is not only the dreamer, but also the doer who is proud of making things happen. Andalas University is committed to realizing its vision of becoming a leader in innovative university education by integrating learning, industry, and community. University always encourages lecturers to create innovations based on science and technology, which are then delivered to the community through research institutions and community service. Andalas University applies continuous quality improvement, improving internal quality through conducting internal quality audits, and designing a curriculum that meets the needs of stakeholders, that is, the world of work and industry. In an effort to produce graduates who are highly competitive, Andalas University also prioritizes entrepreneurship education for students. In an effort to be an international campus, Andalas University is preparing to become a state university. Various efforts to this end continue to be conducted.
Ladies and gentlemen, for your
Students are
information,
given the
we are going
opportunity to realize
start
the
our
issues
event
faced by
again
their
in 2
communities.
minutes.
We
So
encourage our
for
students
those
to help
still
and
want to
serve
have some
others
snacks,
by
you can
offering them
still have some snacks
opportunities
for
to
2
go out
minutes.
and match their skills and abilities to the needs out there. We are proud to have created the university that we have today. All of these things increasingly encourage Andalas University to continuously develop itself to provide high-quality education for the glory of the nation.
All of the participants that's still outside of this room to please come to the room because we are about to begin our event again. Thank you. Ladies and gentlemen, welcome back to the first keynote speech session. This session will be led by Mr. Iwayan Sudiarta, PhD, as the moderator, and we also have we have 3 keynote speakers for this session. There are Professor Stergius Gautianus from Norwegian University of Science and Technology, Professor Mikrajudin Abdullah from Institut Teknologi Bandung, Indonesia, and also Professor Tukfo from La Trobe University, Australia. So I would like to invite Professor Stergius Gautianus and also Mr. Wayan, please to join us on the stage. And for Mr. Wayan, please kindly take over the session. Thank you. Yeah, please come on the stage.
Okay, thank you very much. First thing, honorable rectors, if is still present, deans of faculties, and also the head of the LPMPM, and of all the participants and presenters and keynote speakers, invited speakers. It's a very lovely day to have a conference today. Beforehand, I would like to I was informed that there's a slight changes in the schedule. So we have, where's the schedule? We have the, first we going to have a presentation for Professor Stergios Goutinius, and then we going to have the online session before that. Okay, so before that, I would like to introduce Professor Stergios Goutinius. I hope I'm sorry for my pronunciation. Okay, it's very amazing to know Professor Stergios. His education is recently 2022. He managed to get the pedagogical basic competence from Norwegian University of Science and Technology. It's like a teaching competence, right? Well, it's very nice. And he received a PhD from School of Engineering and Material Science, Queen Mary University of London, and London, UK. And he has research in finite element analysis, structural analysis, and finite element analysis. I saw the CV. It's very nice. He already published many papers. Actually, it's 143 papers since 2001. And also, he has 4 innovations. They call the light switch, glass grid, gas turbine component manufacturers by selecting laser melting and modular gas turbine blades and vanes prototypes. And also he teaches in the Norwegian University of Science and Technology in Norway. I think that's all for introduction. I'll ask Professor Stergios to give a talk for about 25 minutes. So then we get the question and answer sessions. Okay, Professor Stergios, time is yours. Thank you.
Good morning, everybody. Before I start, I would like to, can you hear me? Yeah, I would like to thank you, Professor Buan Ansari, for inviting me here, and also Professor Sarhaman Gia through the WCP program. And also I would like to thank you, the Indonesian government, for the opportunity to be in Indonesia. So now let's go to my presentation, and I will talk about damage tolerance concepts in composite materials, and how we can use cohesive laws to assess the damage tolerance. In order to make the presentation easier, I will use an example, wind turbine blades, as you can see here. And the reason for that is that I can easier connect theory with practical applications. And moreover, I have worked in this area for several years, so it makes easier for me to always think about wind turbine blades. So now, before we go to the main topic of the presentation, let's see how the wind turbine blades have been evolved during from the 1980s up to today. You can see in the 80s the diameter was 15 meters, and as with the years the size increases continuously, and today the diameter is 260 meters, the blades are more than 100 meters long, and to better understand the size of the blades, I have placed here the Airbus 380, So you can see there are massive structures. Why we need to go to larger size? Simply because the larger the size results in a decrease of cost of electricity. Now the problem is that as we increase the length of the blades, which is the x-axis here, you can see that the weight of the blade increases exponentially. And as you can imagine, when we go to very long blades, the weight becomes very critical and can cause failure of the blade. I have plotted here different blades that manufactured in the past, and I have fitted an exponential function. There are many different variations of this graph, but here I have used all the data to fit my function. And you can see here the exponent. If you observe the last point of the graph, you see that it deviates from the trend. That means that we have managed to increase the length of the blade without an increase of the weight that one should expect based on the historic data. How this design has been, or how this less increase in weight has been achieved by using better or new materials. I'm always talking about polymer composite materials, and also by improved design. So from these two, one can understand that if we want to produce an improved blade or a design, we need to combine both material science and mechanics. And here you can see the actual photograph of one of the longest blades, which is 107 meters long. Before going to the technical presentation, I would like to present this equation here, where you can see the cost of electricity depending on many factors. Here is the cost of the turbine. One can imagine that if we use lower cost materials, we decrease the cost of the turbine. If we have a better design on optimized design, we use less material, and again, we decrease the cost of turbine. Less material or lighter weight also results in a lower cost of installation. If we have higher reliability or more damage-tolerant materials, we can also reduce the cost of maintenance. If we manage to have a very high stiffness material, we can make longer blades, and then we can increase the production per year. And of course, T here is the number of years of operation of the wind turbine blade. So we can see from this equation that materials and design have a direct impact on the cost of electricity. And at the end of the day, the most important factor from a wind turbine blade and farm is to reduce the cost of electricity to compete with other forms of energy. When we design a blade, which is part of a wind turbine, we have to make several calculations to calculate the levelized cost of energy. We don't need to go through all these numbers. This is some calculations to calculate the cost of electricity from a wind farm consisting of 25 wind turbines. And we'll focus on this number. This is the levelized cost of energy, and you can see it is 57.87. Now imagine that through better materials and better design, we can reduce the weight of the blade by 20%. This will have a direct effect on the levelized cost of energy by 2%. This 2% is a quite high number if we imagine that the farm will operate for 20 or 25 years. And then we can also see how important it is to reduce the blade mass. Now, imagine that we can use very expensive composite materials like carbon fiber composites, and we can increase the blade length by 50%. That means we produce a lot more electricity. However, the levelized cost of energy increases by 2%. So that's a very typical example in engineering. You always have to find a balance between performance and cost. The best material, it doesn't mean that will give you the best outcome. And my presentation later will reflect this balance between cost and performance. Now let's go to the details of the wind turbine blade. If we take the cross-section here, this is what you see. It's a complex structure with 2 aerosails and a box in between, which is the main loading element. It consists of composite materials and composite sandwich structures. And now if I focus on the main composite lamina here, actually you can see the details here. This is how the microstructure looks. We have many bundles of fibers. Actually, the real microstructure is more complicated, as you can see here from the sketch. And then if we look in more details inside the bundle, we can see how the individual fibers are embedded in the matrix. From this figure, we can see that we have many different scales. From the large scale of the turbine level, we can move downwards, down to fiber matrix level. So if one wants to calculate or to optimize the design of a wind turbine blade or any composite structures, what I'm presenting here, I'm using turbine blades as an example. However, the method is applicable to other structures like aerospace structures. We have different scales. We start from the structural scale, which is the blade. We can move to subcomponent level. For example, sandwich structures with composites, skins, and the core. Then we can, if we consider the skin, we have a laminate, and then we can move at the micro scale. We have the fiber and the matrix, which can be modified at the nanoscale by polymer chemistry. So we can see that we move from several meters to nanometers in different scales. At different scale, we have different, I will say, damage modes. I will not go through all the list, but at the structural scale, we can see that we can have deflection or buckling. At the component level, we can have delamination between the skin and the core. At the laminate level, we can have fatigue or transverse cracks. At the micro scale, we can have fiber failure or matrix crack or fiber matrix debonding. Now let's go back to how a wind turbine blade fails. As you can see from these sketches, we can have many different failures because the structure is complicated and the loads are also, we have different types of loads. The most important thing one should realize is that once we have a damage, this may not be critical, but this non-critical damage can trigger another damage, which may the one that will trigger failure. So not only we have to study how different damage evolves, but also how damage interacts with other types of damages. And just to complete this slide, this is a photograph from where we have tested a blade up to failure, a full-scale blade, and then we have analyzed the different damages we have observed from this experiment. Now, as we move to longer blades, it's very important to introduce the concept of damage tolerance or damage tolerant structural design. That means that our blade should be insensitive to defects, or in other words, the first mode of damage should not lead to failure of the component. And secondly, we have to develop damage-tolerant materials and interfaces. That means the damage should evolve slowly, or sometimes even stop to grow. But it's also important that the damage grows to a size that can be detected by non-destructive techniques. That's the only way that we can understand that our blade is being damaged at some location. Today, how damage is anticipated in practice is that, as I plot here on the x-axis, we have the time, and here is the condition of the blade. At predefined time intervals, now we follow the red thick line. At predefined time intervals, we inspect the blade, and then we can assess the damage. If it is non-critical, we don't do anything. If the damage is critical, we can decide if a repair is necessary or the blade cannot be repaired and is discarded. This happens every year at least, and it's a very time-consuming process. By having damage-tolerant materials and structures, we can avoid all these unnecessary inspections, and we can have our blade to operate continuously. Now the damage grows, but as I said before, the damage will grow slowly, and also the growth is predictable, and therefore we know when we have to stop the operation, repair the component or the blade. So now the blade becomes almost like an intact blade, and then we continue the operation. In this way, we can reduce a lot the cost of maintenance. Indirectly, we can reduce the cost of manufacturing, and therefore we can reduce the cost of electricity. Now let's see how composite materials fail. I will focus in this slide on unidirectional glass fiber composites. And this is an example where I have a DCB specimen, and I will apply forces in this direction and in this direction, so I will open the crack. This is the crack tip here, but you can see that behind the crack tip, there is a large area where fibers are connecting the crack faces. And this is what gives damage tolerance to composite structures. And also, as you can see here, this is the crack tip. All this is the damage zone, so it's a large-scale fracture process zone, typical for damage-tolerant materials. Now, from these observations, we have to move to a mathematical tool that we will use in our design. And the tool that I will use is called cohesive zone, where the damage zone we have seen before, this is the crack tip here, and this is the bridging fibers, can be replaced by a traction separation law. Now, one will notice that there is a difference here. Usually in mechanics, we have a stress-strain curve here. I have replaced the strain with opening. And since opening has units of length, directly we introduce a length scale in our calculations. And this length scale is directly related to the microstructure of the material. And it's also one way that allows us to move from one scale to the next scale when we model a structure. Now let's see in more details what a cohesive law is. Assume that this is the crack tip here. The opening is 0. That means the stress is at the maximum value. This is also called the peak traction or the strength of the material or interface. Now, if we increase the load, the crack opens, as you can see here, but the stress does not drop to 0. This is typical feature of a damage-tolerant material. And this position also here is somewhere inside the fracture process zone. If we further increase the applied load, the openings are increasing, the traction are decreasing, but again, they are not 0. Finally, when the opening is very large, the material is completely broken and the tractions are dropped to 0. Now I have defined the concept of cohesive law. The next step is how we can measure cohesive law in practice. because a cohesive law is a material property, so one should be able to measure it from experiments. I will not go in details in this slide, but I will only mention that we use the J integral. We calculate the J integral around the fracture process zone. These are the bridging fibers, the process at the crack tip. If I plot the J integral with respect to the opening of the fracture process zone, I will get typically such a behavior. And then if I take the derivative, as you can see here, I can calculate the cohesive law. For simplicity, I'll give only the mode 1 cohesive law. That means normal opening on the x-axis and normal traction in the y-axis. I'll go now to the experimental details. We have to develop techniques that we can accurately measure the cohesive laws. This is a photograph from my colleague who developed this technique. This is our composite material, you can see here, and we apply the load through these moment arms. By changing the moment arm, keeping the force constant, we can change the force, and in this way we can test any kind of mode mixity, from normal to shear opening, and also all the phase angles in between. As you can see from the examples here, we have a phase angle of 0, mode 1, and we can go up to 50 degrees. Actually, we can go up to near pure mode to 90 degrees. That's one of these curves here. In more detail, you can see the curve here. We can fit the experimental data and then get the partial derivative to get the cohesive laws. When one develops an experimental technique, should try to avoid errors. In most of the cases that you see in literature, the force is applied by forces. Here we apply moments. And when you apply moments, the J integral is independent of the crack length, so you don't need to measure the crack length, which can introduce a lot of errors when you calculate the J integral. The slide I have shown before, it was an example only for mode 1. In real life, we have to calculate the tractions versus the openings for any phase angle, and that result in 3D surfaces for the normal traction and the shear traction. And since for damage-tolerant composite materials we have a large fracture process zone, we have actually to derive a separate cohesive law for the crack tip and the second one for the bridging zone. Once we have defined this experimentally, these surfaces, we can introduce this material law in a finite element code and model the behavior of a composite structure, in this particular case of a composite wind turbine blade. We can do the same experiments moving to a lower scale at a micro scale. This is the same fixture I have discussed before, slightly different design, and we can insert this fixture inside the electron microscope so we can perform in situ fracture mechanics test. This is a photograph from a specimen from the previous slide. The length is more than close to ½ meter long. If we zoom in here, we can see how the fibers are connecting the surfaces in a 3D space. This is a micro CT images. But if we want to see how the material fails at a micro scale, we perform these micromechanics experiments. And we can see in detail how the crack will grow. So every figure here corresponds to an increasing load. So we can see how the crack growth is affected by the microstructure. Also from this figure, we can see that although we talk about unidirectional composites, the actual microstructure is a lot more complicated because we have the support threads. These are the UD fibers. This is the support thread. These are the stitching yarns where the crack actually goes around the stitching yarns, and this is a resin-rich area. By doing such an experiment, we can understand how damage starts to initiate at the micro scale, and eventually it will evolve at a crack at a higher scale in the micro scale and in the component level. We can also extract the cohesive law, I will say, at the sub-micron scale. I have used the same fixture as before, and I have used silicon plate to model the surface of a glass fiber attached to the epoxy. So in principle, we examine the cohesive law between the fiber and matrix. Again, we increase the load and we record the end opening and the J integral. And the derivative of that will give us the cohesive law at the interface, which can be used in a finite element code. Now I will talk a little bit of crack stability. We have said that damage tolerant means that the crack grows slowly. That means that the energy provided to the system, or the energy rate as the crack grows, should be lower than the derivative of the fracture resistance with respect to the crack length. So this equation should be held. I have skipped many equations in between, and this is our criteria here for crack stability. It's a nice equation because it says that both the material properties through the cohesive law and the structural properties will affect the crack stability. Again, both material science and mechanics are necessary to obtain a damage-tolerant composite structure. We have done some parametric studies with finite element calculations where we have embedded a cohesive zone here and apply forces to grow the crack for different cohesive laws, where we have varied the cohesive law corresponding to the large fracture process zone. We have kept the same fracture parameters for the crack tip. This is the actual cohesive laws, and we can see that as we increase the energy dissipated in the bridging zone, the crack is stable for a larger period. This is how the crack length, and this is the stability criterion. So we see that how the material properties will affect the stability of a structure. Based on these results, we have gone back to the lab, and through chemical modifications at the fiber matrix level, we were able to modify the fracture energy corresponding to the bridging zone, and we were able to increase the fracture resistance of the composite by 3 times. So from the experiments, we have gone back to, from the modeling, we have gone to the experiments, modified the material, and we have managed to increase 3 times the fracture resistance. Now I will speak about strength scaling. We have a long beam, an adhesive joint in between, and this corresponds to the load-carrying beam of the wind turbine blade, and we can see that the failure mode changes as we change the thickness of the lower beam from mode 1 to pure mode 2. Again, we see an effect of the structural design on the failure mode. In practice, we do experiments at the macro scale. You can see the length of the specimen here. We extract the cohesive laws for different mode mixities, and we model the behavior of the specimen. And we can see that we can predict quite well the behavior of the 2 meters beam from data from the different lower scales. So we see how the cohesive law can be transferred across the different length scales. When we design a component, quite often we are based on specimen testing. This is not, in practice, this is not always the best approach because we have many structural features that initiate cracks. So we have to move, and that's what happens nowadays, from component testing and specimen testing to element testing, which can represent structural design features in a simplified way. We have accurate load introduction, and we can follow how the cracks will evolve with the number of cycles. And we can make damage failure maps and identify which crack is the critical one. For example, the red dots show a crack that starts, but then it stops to grow. On the other hand, the blue line shows a crack that at some point grows much faster than all the other cracks. Through these experiments, we can understand which is the critical point of our structure, and we can further optimize this point. I can skip this slide. Now, instead of conclusions, I will talk about future trends, because the time is almost over. Nowadays, we are moving to probabilistic design, and the design now is based on calculating how many blades we are allowed to fail. For example, we can allow, based on our design, that one blade will fail out of 100 blades. The drawback of this probabilistic design approach is that it says that one blade will fail, but not which blade will fail. And that's why now we move to the digital twin approach, where we have our physical wind turbine blade. All the manufacturing imperfections or processing details can be transferred to a digital model. In the similar way, all the damages, when they are detected, they can be transferred to a digital model where we can make predictions and decide how we can operate our wind turbine blade. And with that, I would like to thank you for your attention.
Thank you for nice presentation, Professor Stergius. Now I invite the participants to ask questions in this room or online. So could you please give us comments or questions regarding the talk? Anyone? Please. Maybe to warm up, is there kind of awkward to, okay, maybe some participants in the online can ask the questions or in this room. Okay, one questions. Okay, could you please give your name and your institutions? Thank you.
Okay. One way in design is to avoid delamination, but in this way, you can increase the weight of your component. In my approach is that I will allow delamination to occur. So actually, I want delamination to happen, but I want the delamination to initiate and evolve slowly. Slowly means that I can always have time to react. And once it becomes large in size, it means that I can detect the delamination. And in that way, I will fully use the material for the period of 20 years. If I want to make the blade not to, or if I want the delamination not to start, I will not make full use of the material because the material will never fail. I will over-design the component. So it's a slightly different approach that our design will allow damages to occur.
Thank you. I hope that answered the questions. Maybe two more questions from participants. Maybe online. Okay. Cannot see the chat. Maybe from the chat, Zoom. Can the organizer can check if there is a question in the chat. Okay. So maybe meanwhile, maybe I can ask you a question regarding the damage. The damage is usually between the fibers and the hose, right, or laminate. So is there a way to modify the design so that's the more strong of the so that reduce the damage?
Yeah, from these experiments, you can see that we have damages at different scales and many different damages. So one way, of course, from the experiments and the modeling is to end up with better designs, to minimize damages at these locations or to have damages in other locations. And that can be done through combination of experiments and modeling.
Okay, maybe one more questions from participants in these rooms. Okay, just one. Could you repeat that, please? It's kind of hard to hear from here. Yeah. We could come closer.
The basic idea, yes, you can use it, but all the details have to be different because every concept installation materials, everything is very different. Yeah.
Okay, my second question. I can see in the last slide you mentioned about the digital twins. Okay, may I know what basically the current progress of this implementation for the wind turbine?
At the research level, we are at the position where we have built a full blade, where we have, I have designed some cracks to initiate at specific locations. So we know where the crack will start. So we have placed a lot of sensors to test which technique is best to capture these damage modes. And now we perform the full-scale experiments and we follow how the damage grows and how the techniques will capture this growth. And the final step will be modeling of this crack growth.
Okay, okay, thank you, bro.
Yeah. Maybe one thing that I didn't mention as a current trend is that I have described how you can make a damage-tolerant material, but I didn't discuss about sustainability. And one of other future trends is how to use sustainable materials to make wind turbine blades, but that is another topic.
I think this was very interesting topics, and maybe somebody, if you want to ask, maybe outside this conference, maybe. Okay, I think that's enough for the Q&A session. We should give a round of applause for the Professor Stegerus. Thank you. And then we have a souvenir for Professor.
Thank you so much, Mr. Wayan. So maybe before we continue, yeah. Okay. Thank you so much, Professor Stergios, and also thank you so much, Mr. Wayan. Maybe I would like to interfere a little bit before we continue to the next keynote speakers. I would like to invite Professor Buan Ansari as the chairman of this conference, and also Dr. Dewi Satria Elmiana as the vice chairman of this conference. Also Professor Stergios Gotenus for the souvenir exchange. So here it is. Yes. Okay, thank you so much. Please have a seat. Yes, ladies and gentlemen, maybe you can give a round of applause. Thank you, Mr. Wayan. Maybe I'll hand over the session again to you. For the next keynote speakers, there are Professor Mikrajudin Abdullah from Institut Teknologi Bandung, Indonesia, and also from Asok Professor Dr. Tukfo from Lathrop University, Australia. Yeah,
Okay, thank you very much. I'll ask Professor Mikrajudin Abdullah. He's already joined the Zoom meeting, and also Professor Tukfo, the next presenters, keynote speakers. So before we continue, I'll a little bit introduce two of our keynote speakers today. The first one is Professor Dr. Eng Mikrajudin Abdullah. He is the staff faculty members at Institut Teknologi Bandung, Indonesia. He is chief doctor at Hiroshima University, Japan, and magister at ITB, Indonesia. And he research is nanotechnology, polymers chemistry, and material chemistry. The latest publication is the effect of TO2 photocatalyst toward methylene blue degradation using simple deep coating. Okay. This third keynote speakers is Associate Professor Dr. Tukfo. He is at the Department of Civil Engineering and Physical Science at Lathrop University of Australia. His education, he received a PhD in engineering in Sejong University, South Korea. And then his research is mainly aerospace engineering, civil engineering, and mechanical engineering. And his latest publication is a finite element formulation of metal foam microbeams by modified strain gradient theory. And yep, I think that's what I have information here. Okay, I would like to invite Professor Dr. Mikrajudin to join us in the Zoom meeting. Okay, so right, you have about 25 minutes to present your talk, and then we after the third speakers, we will have the discussion or questions. Thank you. Time is yours, professors.
Thank you very much. Good morning, ladies and gentlemen from Mataram University. Thank you very much for inviting me as one of the invited speakers in this meeting. Sorry, I failed to change the background of this screen. I have tried several times, but failed. Now let me share the screen to show the title of my speech today. Okay. Can you see the screen? Is okay?
Yes.
Okay, this is the
you.
title of my talk today. It is not related to the new technology, new research finding, but it is just a simple talk. And my objective is to share experience to my to young researchers. How to survive in research in the condition when our institutions are not facilitated by adequate by equipment, or we didn't get any fundings to do the research. Let me change this is the content of this research is not the high quality research, but just to share my experience to do research in any condition when the facility, when the funding are not coming to me. So how can we survive in that condition? How can we still can do research, and how can we publish paper in the journal if that condition is belong to us? Many researchers always saying, we have no equipment, we have no money to do research, and finally they didn't produce any research finding. But now I will share my experience, especially how I can, or also my friends can still produce research findings even the equipment or research budget are not available for us. So the topic, the content of my talk right now is more related to spirit, motivation, or
excuse me, professors. I'm not hearing. Could you check the connection or the microphones? Okay, maybe there's a technical problems. Okay, you speak. Okay, we are waiting. Maybe we need help from the organizers to check the connection. We didn't hear any. Okay, maybe it's this computer problem, I think. we can see the videos, the presentation, but not hearing any sounds. Just we're waiting. Nothing we can do. We are deeply sorry for this connection problem.
Recording in progress.
This is our work. This is very simple. And I think we do this in Indonesia every year during takbir night. We play firework, we fire firework, and then with children, we play in the malam takbir night. And what happened with this one? This is just simple. And no one thinking about the physics of this process. But when I see the firework, if we fire from this point, the top point, and the angle of this fireworks is different, the bending profile will be different. So this is nearly vertical and only slight bending. If this is the angle is reduced, the bending increase, and if the angle is reduced again, the bending will be greatly increased. So the problem is the physical equation to explain the bending geometry of the firework. This is maybe no many people ask this question, but I thought, this is very interesting. Maybe the physics equation can be used to explain this phenomena, this geometry. So our work is to develop physical theory, physical equation to explain the bending behavior, bending geometry of the fiber. And we develop a theory, we propose a hypothesis, we derive the equation, and we finally obtain the equation to explain the bending of the fireworks rod. Okay? This is the equation. And then we also do experiment using fire rod of the length about 40 centimeters. And we see here that the comparison of the theory, our theory, and the data is pretty good. This is the experiment, the black one, and the color one is our theoretical prediction. Also this one, this is a symbol, is the experimental data, and the curve is our theoretical prediction. This is, I think this is a very nice agreement between our theory and the simple experiment result. So we also use the very long firewall, but this is not commercially available. So we connect several firewalls using this electrical connector. We connect, and the black one is the experimental result. The blue is our theory. It looked like a good agreement, and then finally we get the paper. Now, what is the price? The budget for this research? It is about several 100,000 rupiah, less than 1 million rupiah. So, with a few hundred thousand rupiah, we can obtain one paper. This is very reputable journal in physics related to education. So we obtain this paper just by buying a firewall, several packs, and then develop theory, do simple experiment, and then obtain the data. This is the next. So we always do this one maybe every day before we drying the clothes, we rotate the cloth to remove water, and then we put in under the sunlight, and then the cloth will dry. This is just simple. Every day we do this, but we never think about the physics of this activity, the science behind this activity. We think that, we thought that. So our observation is, if you do at home, if we rotate the cloth, at first the water doesn't come out. But if rotate many times, the water come out, and we increase the rotation number, the water stops. The question is, are there physical equations to explain the coming out of the water when we turn the wet cloth first? So we derive a physical equation. We develop an equation to explain the process. So we hypothesize that at initial, the cloth contain water and also empty space between water inside the wet cloth. If we rotate the cloth, we just remove the empty space. And then if we rotate again, we remove water, and then finally we cannot remove anything. So this is our hypothesis, the process where we turn the wet cloth. So this is our equation. You can read it from the paper. Finally, we obtain the volume of water displaced from the cloth is satisfy this equation. This is the critical angle. This is the angle of rotation, and the equation is this equation be tested with that experimental data. So we develop experimental. We develop a new simple experiment equipment to test our theory. This is wet cloth, and we rotate this by rotative handle, and then the water will falling on the container, and then we weight the container as a function of the rotation angle. And then we find symbol is the experimental data. This is the theoretical prediction, our model results. And finally, we compare all of the experimental data, and it fall in one single equation from our theory. We see that the experimental data are in agreement with our theory. This is our theory. This is experimental data for many kind of cloth, towel, batik, and then finally it end up in this paper. Also European Journal of Physics. This is related to education, but it is high quality journal in physical science. This is from Bima. Bima. I also from Dompu. When we use it, this is just simple. Every day, maybe before we pray to go to mosque, we use this sarung. This is me. This is me. This is me. We put this sarung. How to put this sarung from this one, and then we fall, and then we tear this one. This is very. After this one, this is very strong touch on my stomach. Bengali in Bima language, Bengali. This is me. Okay, the process. Why this is so strong? Attached to the our stomach is so strong. Is any equation, any physical equation to explain this phenomena? So, if we observe, just by folding and rolling, the sarung is attached strongly on our stomach. If the number of rolling increase, the attachment gets stronger. And if the pressure of the sarung to our stomach, the attachment is also stronger. So the question is, are there any physical equation to explain this phenomena? Just everyday phenomena. We do it every day, but we never think about that. So I do experiments to measure the pressure between sarung and stomach. This is me. I did experiment at home, and this is we design simple experiment by measuring the difference on the water level inside the pipe. From the difference in water level, we can determine the pressure of air in the balloon. This is balloon, and then we also design using kitchen utensil. We design experiment. This is very cheap, maybe several 10,000 rupiah. We can obtain this equipment. And then we also do experiment using paper, photocopy paper. We fold and roll the paper, and this is data. We collected data and we compare with the theory prediction. This is theory prediction. The line symbol is the data. We obtain a good agreement between the theory and the data, experimental data. This is a theory, this is experimental data, symbol is the data, and line is our theory prediction, and then it's end up in this paper. This is my son and father. Okay, this is also my experience when driving in a wet and rainy day. The mark, this is the Bali Mandara toll road. In the dry condition, we can see the mark very clearly, but when it rainy, the mark is blurry. It's very difficult to identify the road mark. So the problem I am from physics department, why this mark is blurry when the condition is rain? This is theory. So to answer this question, we do experiment at home during the COVID-19 pandemic. This is at home. We design experiment. This is camera, and this is the root. Root is from the plate, and we painted black paint hit the road, and with a stripe, white stripe. This is equipment we make. This is the imitation of the road, and camera so we take the image of the root surface under the dry condition and under wet condition, and we also do experiment using this photoresistor and light source to determine the transmission of the root surface. And the model, we do also the model, and this is our experimental result. This is experimental result symbol, and then this is the theoretical prediction. This is a very nice agreement. This is just simulation, and this is the experimental result. This is our theory, also good fitting. And finally, and this we also examine the color spectrum of the road surface. And this is end up in this paper, European Journal of Physics Education. This is also good journal in physics education from European Physics Society. This is my son. Traditional steers. Traditional steers mean in Indonesia egrang. Egrang. Why? The problem is why playing egrang is very difficult. You see, The idea originated from the YouTube video. I watch a YouTube video. I enjoy the steel demonstration by many people, and
Excuse me, professors. We need 5 more minutes.
Okay.
Thank
Yeah,
you.
yes.
I'm sorry.
minutes?
I apologize. Thanks.
Oh, okay. This is the traditional. Maybe we have experience to play this one. The question is, what causes the steel stable? Why is it difficult to start playing steel? And if we look closely to these steels, for physicists, for physics lecturer, we can see that the movement of the steel is combination of two movements. The first one is the physical pendulum, and the second one is the inverted pendulum. Yeah, there are two movements. Half period is like physical pendulum, and the second period like inverted pendulum. The question: are there any physical equation? So this research is also very cheap. Just by buying the bamboo rod, several bamboo rod, we make the steel, and then we are very cheap. And we derive equation from physics point of view. We finally find this equation to explain the movement of the steel. So this is my son with the steel. He trained this son about 1 month. And we also determine the pressure by foot when he is playing the steel. This is our foot, and we measure this using a camera, place here, and then this is bathroom scale, and we observe the movement of this one scale of the bathroom scale, and from that we can determine the time depending of the foot force. And we obtain this data. This is the observation, our observation, the dependent of the footstep force on time based on the video recording. And then this comparison, this is the comparison of the data. We collected the data and our theoretical prediction. This is our theoretical prediction, the proof. The symbol is our data measured from the balance bathroom scale. And we find this is nearly in agreement with between the data and the theoretical prediction. So this is also the result, and this result finally published in this journal. This is also related to education in physics, but we can produce paper. This is a high quality journal in physics related to education, but we can produce paper with a very cheap budget, very small budget. Also, maybe we enjoy this one in Bali, especially in Bali. This name is Janggan. The name of this kite is Janggan. It's a very long tail, about more than 100 meters, and it oscillates beautifully when it is playing. The data, the idea of this research originated from the YouTube video. I was watching YouTube video related to the large kites in Bali, and then I see the oscillation of the tail, and it's very beautiful. The question is there any physical equation to explain the oscillation of the tail? See, the experiment is this research is very cheap, but very beautiful. Are there any physical equation? Or we derive equation based on our experience in physics, our understanding in physics. This is the kite tail. This is wind, blow, and then also gravity act together to form to control the shape of the tail. And then we obtain 3 types of bending. And the first one, second one, and you can see from our paper. You can read from our paper. And finally, it end up in this journal. This is just by looking YouTube video, by watching YouTube video, we can obtain a paper published in a good journal. This is a very cheap research. And this is also maybe a type. This is also another our research. If we use a fry pan and we put a butter on the pan, and we will see that melting process starts from the bottom of the butter and then goes up until the butter finally melts all of the bottom department, but starting from the bottom, from the head. This is the head portion. Now the problem. This.
Excuse me, 1 more minute.
1 more minute.
Thank you.
Okay. Okay. This is this is we model this equation, and then we model as a zipper, and then finally we obtain this paper. I just saw this is Flying Garuda Indonesia. Maybe we frequently use Garuda Indonesia, and then we do experiment in the cabin, and then finally we obtain this paper, experiment in aircraft cabin. This is very cheap. We don't need to use budget in this experiment. We also have paper in granular material. This is what I can see during Idul Fitri or Idul Adha. This is a general cake in during Eid, Idul Fitri or Idul Adha. And then this is unexpectedly, we develop a theory to explain the rolling of this one, contain rice, granular. And we obtain the theory, equation, and we use this granular. And finally, we obtain this paper, Powder Technology. This is a very good journal in material science. Okay, we continue this research using the cake box. We develop a theory also, and we also do experiment, and finally we obtain this paper in Powder Technology. And then this is when I watch video, we also obtain from this paper disaster when digging a tunnel on the beach. The question is, can we obtain the stability criteria for the tunnel to stay, to avoid the tunnel from falling? Okay, we develop theory, we do experiment, and we do data, and finally we obtain this paper from the granular matter. And also, this is very simple. If you go to Senggigi Beach, and we stand on the sand, we will obtain that if the sand is dry, our foot will be fall down, and if we very wet, it fall down also. But there is a critical condition when our foot is stay on the top, on the surface, and we develop a model theory, and this end up in this paper. And this is beautiful sand surface, granular surface, curve, like a curve. This is curve, not a straight line. We obtain the theory, 1 minute, and then we compare data. We do simple experiment, and then we end up with this paper. And this is also we do this. We did this at the home or the house at the home during pandemic, COVID-19. Simple experiment, camera, and then this is. Spaghetti, and we use this spaghetti. Maybe most of you have experience to eat this spaghetti. And then we decide experiment, theory, and this is theory and experimental. Experimental symbol, theory is line, and then we end up with this paper. This is me and my son. Cutting glass, this is also from YouTube video. If you need to cast the bottle, we can use a hose wire, and we develop a theory to determine the thickness, critical thickness of the bottle. And then we end up with this theory. This is also, this is also a traditional activity. Winnowing rice to separate the small and larger grain. We develop experiment, simple experiment. We use simulation, and we end up in this paper. And bending paper, and this one, and this is a tangle in Indonesia, benang kusut. Okay, why the benang become kusut? This is the question. Okay, we develop a theory. You can read from this paper, and then we obtain that. Finally, find that our paper published in this journal. Thank you very much for moderator. Just simple talk.
I just can say wow. Very nice. We should move to another keynote speaker, and then after that we're going to have a discussion. I'll ask Associate Professor Dr. Tukfo, are you present or join our Zoom meeting? could you organizers check if there's associate professors already joining our Zoom? Okay. Okay. We waiting for the associate professor. Maybe while we are waiting, we can ask a question from the audience or the participants of these rooms or in the Zoom. Could you please all ask questions? Very nice questions. Thank you. Okay. Should be questions. Very nice presentations. Okay. Anyone in this room or in the Zoom room? Maybe through warm up, I will ask one more questions before waiting for other participants. Is there maybe I was wondering, I'm also a modeler also. Is there a way to actually develop equations? Is there a trick or methods, or how do you actually develop your equations? Thank you.
Okay, thank you very much. Maybe because I'm a physics from physics department, then we have we have a lot of experiences to see the phenomena around us and thinking about what kind of equation can I derive to explain the phenomena. All of that is based on our learning in BSc, also during our master degree. In my opinion, we have studied many equations during in our classroom or when teaching students, that if the profile of something is like that, the equation must be like this. So our process is how to find that equation. For example, if the bending is like this one, maybe this is like a Bessel function. I think this we are thinking about that. Likely this is a Bessel function. So I have to try to develop a Bessel equation for that process. So the final result is I can compare our Bessel curve with the experimental data, and then we find the agreement. So we have to think from the first time that I have to find this equation. So after thinking about that, we can start from what point I have to start to be able to get that final equation. So developing a theory, not arbitrarily, but this is a political approach. We have to think about, I have to find this final equation. Maybe this is a four-year series. So how to start the process of deriving equation? So the final one is the four-year series, like that. Not to blank to not like that. This is political in developing equation, like that.
Okay, you mean that we need to have read more, experience more on other equation or other field, so then we can use that equation to other fields, right?
Okay, yes, exactly that.
Yes, okay.
So, for example, if I look at the oscillation of the kite, a very long kite, I observe, oh, this is like a Bessel function, this oscillation profile. So I have to derive Bessel equation to explain the oscillation of the type. Like this one. No? Okay. The deriving equation in physics is not a blank, but it is a political approach. We know the result. So when I have to start to get that result? Well, thinking about the result and then arrange the starting point to get that result. This is so political. That's what I think. I hope this can be understood.
Thank you very much. Maybe ask the participants of this conference to ask more questions while we are waiting for the next keynote speakers. Okay, okay. So there's Professor Tukfo has already joined our Zoom meeting. So how are you today?
I'm good. I'm
Okay.
sorry for late because I thought it's the 2:45. I think a bit late. I thought a bit later, so that's why.
Yeah, that's okay.
Sorry, I'm late.
Okay. So you ready to present your?
Oh yes, I'm ready now. We share my screen now.
Okay. Can you share your screens? Thank you. And you have 20 minutes for your presentations.
Yes. It's my pleasure to present the topic dealing with machine learning for structural engineering application. I'm Tuk. I'm from La Trobe University in Australia. That's the content of my presentation today. Very shortly introduce about myself a bit, and then talk a bit with machine learning models and some application. We propose some machine learning model for compressive strength of hyper performance concrete, and then we also do compressive strength of concrete filled steel tubular member, and the next one we try to present something about semi-empirical formula. It's just
Excuse me.
like,
Excuse
can
me.
you hear me? Something wrong?
Did you
Yes.
share your screen?
I already said it.
Thank you. Okay.
You see it?
Yes. Thanks.
Yeah, sorry about that. And then the next part is just provide some formula. It's just like to overcome the problem with black box models of machine learning models. And again, we try to visit some classical model of high performance concrete and then ultra high performance concrete. So that is a bit about myself. I got my doctor degree in South Korea in 2010, and after that I went to University of Liverpool to work at the research associate 2010 and 11. At that time I met one of your colleagues there, Professor Buan there. That is during that time he did the doctor degree in there. So that's the time we met him. It's quite a long time now, around 10 years now. And after I stayed there for a year, and then I worked at Glendale University for 2 years, and then later on I worked in Northumbria University in Newcastle for around 6 years, and then I moved to Australia 3 years ago, just exactly before COVID happened. Now I just give you very briefly about machine learning models. So just the idea of machine learning model is just using computing-based system to extract the pattern, fit data, and to classify data. So machine learning system learn and improve the data, and it's just a combination of theoretical computer science and real noise data. The way how it works is we define the objective. So we can define something like, for example, can be compressive strength, can be strength, or something similar. We do some data preparation, normalization, transformation, try to see the data, what happened with the data, is it mixed in values or some outlier for the data, and from there we begin to build the models, and we do some evaluation of models, and then we come back to improve the models. So that is the way how we dealing with machine learning models. So we that picture show you that around 19 selected industry have potential with incremental values benefit from machine learning. So that is the travel machine learning using more than, the benefit more than 100%, and then for logistics around 89%. However, in terms of engineering, we talk about electronics and semiconductors and aerospace. The percentage is quite low. So around 26 and 30% is here. So that is the reason why I think there's some need for machine learning for civil engineering. So that data probably changed now because that on the figures here, I take it from 2018. So probably a lot of things changed now. So in terms of the civil engineering application, machine learning application can using for main area. So the first area is predicting the structure response performance. So that is dealing with the building models and building response and then building performance. We can dealing with some information using image or written data text. And another thing dealing with recognize the pattern of structure how monitoring data. So that is and then the last thing, and that is the last thing, that is the main thing my research focused on. We try to translate, we try to interpreting the data from experimental, and we also dealing with the simulation data. So when we're using with abacus modeling, we try to get the data from there, and then we try to using for experimental. So it's mainly for concrete. So briefly introduce about high performance concrete and then ultra performance concrete is they're using quite a lot in tunnel, bridge and pavement or some high-rise building because the strength and because the very high modulus of elasticity. For ultra high performance concrete, the compressive strength can be from 150 megapascal to 800 megapascal. And another area we also doing is conform steel or concrete filled steel tubular. So that is mainly using for the bedding frame and floor frame, that kind of structures that we call concrete filled steel tubular. So the concrete is filled here, and then the outside is like the steel structures is covered outside. So it can be have a circular section or can be have a rectangular section. So the big problem when we're dealing with the experiment is we have many components, for example, like concrete, for example. So that means why if we talk about ultra high performance concrete, we talk about 15 ingredients of them. So if we do experiment, so if we say 15 of them and then 5 different values of 15 of them, so the total number of experiment we need to test is that kind of number. It's a very big number. So that is very challenging. It could be time consuming and then the monies and costs and everything. So that is why machine learning models can be using to solve that kind of problem. So when we talk about conform steel structures, when we model that kind of thing there, it could be time consuming when you do experiment and then when you do final element. So because the natures of nonlinear relation between of input and output variable, so we can again exactly the same thing with experiment by of the concrete. We can dealing with that kind of problem using machine learning model. So the framework of machine learning models can be summarized on this slide. So we can have we can collection data from either experiment, or you can collect from commercial finite element simulation. So what we need is we're mapping between the output and input. What you're looking for, that what kind of parameters study, what is the geometry, what is the material property. That's something we call the input. What we're looking for is compressive strength, shear strength, bending strength, that kind of thing we call the output variable. So we're mapping them. We know what we're looking for. And then we're using some traditional machine learning models from computer science, XGBoost, AdaBoost, CardBoost, that kind of thing. It's quite traditional from computer science. And using that kind of models, we beginning to build a model we call model prediction. In order to dealing with that kind of thing, we need to choose the hyperparameters. We need to choose. We need to select the best performance. It's just like verification, and it's not stopping there. So we go ahead with try to explain how the model works. Try to explain, what is it reasonable, or try to get some optimum value. Because very challenging when we do experiment is it's very challenging when you get optimum value. But the machine learning, because when we have a big data, we can get that target. So in order to assess the performance, there's some fundamental parameter we need to consider: linear correlation coefficient, root mean square errors, mean absolute errors, and mean absolute percentage errors, that kind of thing. And if R square or A20 index is close to 1, that is a good models. And then the lowest values of RMSE, MAE, or MAPE, the error is less, the better prediction is A. So by using some framework like that, we present some of the research we do from last year until now. So just gives you some information about application of machine learning model we're using. So we developed the prediction of compressive strength of high performance concrete. So we're dealing with two data sets. The first one is we have more than 1,000 samples, and the second one we have more than 700 samples. And as you see here, we have quite different kinds of input here. So this is around 10 input variables, and the output only 1. So for this, the first one, there's nothing about missing data set there. So it means that all the data is perfect. And for the second one, a little bit challenge when we have some missing data there. So for example, concrete compressive strength, we have 35% of missing data. The missing data is dealing with the human errors, or because when people took experiment, they do not record the value. So that is why we have some missing values there. And this paper we published last year. So we try to get the compressive strength and compare with some other people. They did it before. So the two main contribution of this research is we try to handle some missing data, and we try to get some optimum values of hyperparameters, and we compare with some other values of some people they did before. So we also try to get some correlation matrix for the feature in data set. As you can see there, we can have some full pictures of what relation of what kind of effect of each ingredient to others. So that is a very good thing of machine learning models. And when we that is some comparison when we compare with some other people they did before. We compare with the time we perform, so that is some reference we got, and that is our model we present here. So in terms of the time we present, for example, the reference trial here, the time, the second is 900 seconds, but in our model, the maximum time we spend is around 90 seconds. So that is a big advantage compared with some other model they present, because we optimize the parameter, we got the best performance. And for this paper, we decide to publish on the code. So if people interested on that kind of model, we can happy to share, and that is open access for that kind of code for this kind of problem, because that kind of problem become fundamental when we have the data set, we can using for different kinds of problem. So the next problem we also try to do is we try to do with CFST. So as I mentioned before, they have a different kind of section. So they have circular section. At the same time, they have a rectangular section. So they have a different kinds of long and short column. They have a different kinds of parameter dealing with use strength of steel, and then we have also concrete strength. So that the value is very, very different. So totally we got around 3,000 sample, and with four data sets, so we divide to short column and long column, and from circular columns, and then for rectangular columns. So we have totally 4 of them. And the problem of the some code, current code at the moment is like ICST or Eurocode or even Australia code is they cannot cover on the rank of material strength. So if you look at this one here, for example, if we talk about the U strength or FY, the Eurocode 4 is just only the value between 235 until 465, and then even for Australia code they cover just the maximum is 760, 790. And ICST just cover from 555, and even for concrete as well, the cover something like that here they cannot cover. We can do experiment on that, but on the code they cannot cover all of them. So that reason why one of the very strong tool we're using here, that is the machine learning models, and very specific model we're using here, that is Catboot model. So we by using the machine learning model, we can learn about what is the most important factors that have a strong effect on the strength of these kind of structures. And if you look at this one, you can see that the main factors affect the performance is mainly the geometry. So it means that, for example, for circular, so that is diameters there, and then the same time is the corresponding to thickness. And it's the same thing for rectangular one. Okay, so it's mainly the geometry and the thickness. We will also try to compare the prediction of machine learning model with some other code available. And you can see here, we got compared with 3 code available there. Different kinds of color were present for different kinds of code there. So as you will see here, that is the machine learning model. And you see that, for example, the blue one that present for ICST is a bit out compared with experimental. So we also try to compare the effective of machine learning model compared with the code. For example, for data set number 1, for our model, we can predict correctly 91%. 91%, the error rank is just only 5%. I mean, it compared with experiment. However, for the code, for example, ICST, 12%. And then Eurocode 4, 44%, and then Australia code, 46%. So the prediction by code and the prediction by machine learning is a big gaps there. And it is exactly the same thing for some other data set. So for home data set for 3,000 sample, the percentage error for 5% is 91%. So it just only 91% for 5%. So it's very high accuracy compared with some other code available. So we also to try to compare with them, and then probably it's just mainly for that kind of specific problem. All the code we consider here is underestimated column capacity. And Eurocode 4 and then Australia code give the best prediction, and most conservative one is corresponding to ICST. So this highlights the novelties of a machine learning model to predict the strength. So as you can see here, I present 2 problems we're dealing purely with machine learning models. As you see, it's very high accuracy, and it can be predicted well with the problem we're dealing with. However, as you can see there's some problem because it's mainly dealing with the black box nature. Even though it's powerful prediction, there's some limitation. There's something about you cannot explain how it works. So that is why there's something later on for we say we try to do something. I mean, it's not we just mainly using, some people do it before. We're dealing with some explainable machine learning model. So try to explain the black box model to see how it works. So in order to dealing with that, we try to propose 2 ways. So the first way, we try to provide some semi-empirical formula. So we can see the relation with some ingredient on that, relation between output and then input variable. At the same time, we also try to present something we call partial dependent plot. So you can see the relation between input and output. So we So we visit again some high performance concrete and then ultra performance concrete, and to see how it works. So the first one, as I mentioned before, it is similar to problem I solved. It's very traditional problem. So, but in this case, we try to provide something about formula rather than purely machine learning model. We try to using machine learning model, but we try to provide some formula. And we're using something we call non-dimensional and then optimization. And we have dealing with 5 data set, around 2,000 samples. So the way we try to derive the formula for that is we're using mainly non-dimensional variable. So we try to define non-dimensional value for some ingredient of concrete. For example, C present for the concrete, and then W present for waters and coarse gradient, aggregates, and that kind of thing. So we try to get some optimization that, and then finally we come up with that kind of formulas there. Okay, so that kind of formula there, B1, B2 until BA, and then alpha, beta, gamma, delta here will be depends on that kind of parameters there. So for each kind of data set, that kind of number will be different. So that is the fundamental why we go up with this one. So we do some comparison with some other people. They do purely on machine learning model, and the result quite well. The good thing of this one is we can see the relation. You can see in terms of number. We can see it. You can feel it, rather than we just see the accuracy. So that is one of the main contribution of that paper. So we also try to plot something like that, and as you see here, some of the point we mentioned here, that is experiment data. So we try to get the verification. It's not only a machine learning model for R-square or something like that. We also try to get a bit further when we plot some curve, and then this curve will be passed through some experiment results here. And as you see here, that the nonlinear relation, and is always passed through some experiment data set there. So we try to do a bit further for another data set we call ultra high performance concrete. For ultra high performance concrete, we have a 15 ingredient, and data set we're dealing with is more than 800 data set. As you see here, we have 15 of them. We also developed this one for machine learning models, and it agree well, very good accuracy. But we want to get a bit more for formula, so that's why we go slightly different approach for this one. So we're using two approach here. We're using Lasco and auto-fit model. And as you see here, we also try to compare with some experiment data here. So that's this one is the real data, that is experiment data. And you can see here the accuracy is very good one. R-square is almost 1, so it means that very high accuracy. So the formula, we also derive the formula here. So in this formula, you can see what kind of relation, what kind of the most important things of fact. So it's on 15 ingredient will be included in this formula. So if you want to find anything, you can using that kind of formula. You put on the ingredient here, and then you can find the values. So that is the good thing when we have the formula. So when you have the formula, you don't really need to worry about what kind of thing or what kind of number you estimate or something like that. We just put on the number here, and then you get the value. So in order to go a bit further, we also try to plot some relation. So that we call that's something we call patio plots.
Excuse me.
So.
Yeah.
Sorry?
You have 5 more minutes.
Oh, yes, I'm nearly there.
Thank you.
And you see here, we got the relation for one variable. So, for example, if we got the curing longer time, we have the strength develop more than that. Okay, so it gives you some pictures about the relation. And we also try to plot the 2D one. So the 2D one is, you can see the relation. For example, in here, relation between the concrete and waters there. So what is the optimum values of the concrete, how it look like, and what is the values optimum of the water percentage. So we also try to provide something about graphical user interface. So it based on, it's based on machine learning models. So when you have all the value here, you put all the value here, and then you predict, so you will get the values of the compressive strength, for example. If you want to see the relation between concrete and slag, for example, you just put here, and then you plot, and you can see that is a 3D relation between them. So again, it just give readers a bit more details about relation between them. So that is the end of my presentation, and thank you very much for your time.
Okay, thank you very much. Okay, we still have 10 minutes for our discussions. So could you please, the participants of this conference, to ask questions? Okay, Prof. Buan.
Hello, good morning.
Oh, hi, Buan. How are you, mate?
I'm fine, thank you. I took.
Thank you for inviting me here.
Okay, thank you very much. You look younger, I think. How many kids now?
Yeah. Oh, good now.
Yeah, it's about 10 or 11 years we met in Liverpool.
Yeah.
Yeah, it's very interesting topic about machine learning model for structural engineering application. You still very advanced in this. You still what kind of software you still use Abacus in a software in?
Oh yes, I'm still using Abacus, and yeah, machine learning model is just something quite new for me from last year. Yeah, we tried to do something from last year with machine learning models, and I'm very lucky to got some people dealing with machine learning models, and but Abacus and then finite element model is still my favorite thing to do.
Any limitation? I mean, any limitation for this new method? Like, what's the minimum requirement for hardware to run this model?
I think the in terms of the hardware, I'm not quite sure about the hardware, the software thing, but there's some limitation dealing with the machine learning model for that kind of thing. If you look at the way I'm present here, it's always come up with minimum and maximum value. So it means that it's only the machine learning model just only correct when the values of concrete or fire aggregate is between the minimum and maximum value. So that is present for something you do in an experiment. So if you put the value outside minimum and maximum, your machine learning model cannot be correct. So that is something about limitation of machine learning models. And another thing for machine learning model for me is that is a black box model. So so it could be prevent people like us. Like if we want to do more about physical thing, we want to see more about, if you do experiment, you can feel it, you can see how it works. But when you do machine learning model, you just get the result. But in terms of physical meaning, that will be, you will lacking that kind of thing.
Okay, thank you. It's very pleasure to see you again. Thank you very much.
Oh yeah, thank you, Buan. Thank you for inviting me here.
You're welcome.
Okay, still have times. So, any more questions? And you can also ask for the previous speakers, Prof. Mikra Judins also, not only Prof. Tuk. Okay. Okay. I ask participants to ask one more, maybe. Online, maybe.
Yeah, we have one funky Darren.
Okay, thank you for the opportunity. Hello, Dr. Tukfo.
Yeah. Hello, nice to see you.
Okay, great. I'm sorry, I just asked one question about what is the minimum data it can use of machine learning, because if we have experiment data, is very expensive to reach the 2,000 data.
So, when you have the data, for example, you will have some minimum and maximum. It's like when you collection the data.
Wow.
So we have a different kind of number in data, right? So we have different kinds of experiment, right? So for one of them, you will have the Siemens is very minimum values, and Siemens will be maximum value. So that reason why the minimum maximum is just like we collect from the data. So the minimum in the data and maximum in the data. So that is the meaning of minimum and maximum there.
Or just the between of the range.
Yeah. That's just the range of experiment you do. That's just the range. Yes, that's correct. Correct one.
And one more question, please.
Yeah, that's fine.
Okay, what the difference about the artificial neural network in machine learning? Because I use artificial neural network, and the data is divided about the three: data setting, validation data, and testing data.
I think it's almost the same thing, right? It's almost the same thing when the language we're using. It's almost the same thing, right? Yeah, model splittings and verification. I think for me, it's almost the same thing. Yeah.
Okay.
Yeah.
Okay, thank you, Dr. Tukpo.
Yeah. You're welcome.
Okay, all right. Any more questions from this audience in this room or online? Okay, maybe that's enough for this session. We should give a round of applause for 2 our speakers. Professor Mikra Judin and Professor Tuk, thank you very much for presenting your talk, and I'll give to MC. Thank you.
Yeah, thank you very much. Bye now.
Thank you so much.